Hello, my name is Marie Lutz-Chiorean, and in this video I will be focusing on solving questions related to exponential decay and determining the first derivative of an exponential function. To recap, an exponential function is a function that has the form of y equals a times b to the power of x, where a cannot equal to 0, b is greater than 0, and b cannot equal to 1. There are two new things that we will see in this video: first derivative and exponential decay. A derivative for a function y equals f at x, the derivative is the slope of the tangent to the graph of y equals f at x, and an instantaneous rate of change of y with respect to x. Therefore, the first derivative would be the first derivative of a function y equals f at x and is identical to the derivative y prime equals f prime at x. Exponential decay occurs when a quantity decreases exponentially over a period of time. In this video, I will walk you through question number 3 on page 290, section 5.5 in the grade 12 McGraw-Hill-Ryerson Calculus and Vectors textbook. The question states that as radon decays, polonium is produced. The mass of polonium MPO in milligrams as a function of time is given by the function MPO at T equals MO times 1 minus 1 over 2 to the power of T over 3.8. where MO is the initial mass of radon and T is time in days. A. How much polonium is there? 1. Initially. 2. After 1 day. B. Find the derivative of the function. Explain what it means. I will now reread the question and highlight the key points in yellow and what the question is asking us to do in blue. Our key points are the mass of polonium MPO in milligrams, the equation of MPO at T, MO is the initial mass of radon, and T is time in days. And the question is asking to determine the amount of polonium initially and after 1 day, and to find the first derivative of the equation and explain what it means. We'll first focus on 3a. The question asks us to determine how much polonium there is initially and after 1 day. Here is how I plan to solve 3a. Step 1. Determine and organize needed information. Step 2. Determine values for given variables. Step 3. Substitute determined values into the equation. Step 4. Therefore statement. Step 1. Determine and organize needed information. Here's what we need to know to solve 3a. The amount of polonium in milligrams can be found using the equation MPO at T. T represents the time in days, and MO represents the initial mass of radon. Step 2. Determine values for given variables. 3a asks us to determine the amount of polonium at 2 times. Initially, which means that the time in days is 0, therefore T equals 0, and after 1 day, which means that the time in days is 1, therefore T equals 1. Now we need to determine the value of MO, which represents the initial mass of radon. Using common sense, we know that initially there would be 100% of radon, since none of it has decayed and produced polonium yet. Therefore, we can say that MO equals 100. Step 3. Substitute determined values into the equation. For 3a1, the value of T is 0 and the value of MO is 100. By substituting these values, we can see that MPO at 0 equals 0. For 3a2, the value of T is 1 and the value of MO is 100. By substituting these values, we can see that MPO at 1 equals 16.7. Step 4. Therefore statement. Therefore, the amount of polonium initially is 0 milligrams, and the amount of polonium after 1 day is about 16.7 milligrams. This makes sense because if you look at the graph of MPO at T, you can see that when T equals 0, MPO equals 0. When T equals 1, MPO equals about 16.7. We are not done just yet. Part B of the question asks us to find the first derivative of the function and explain what it means. Here's how I plan to solve Part B. Step 1. Determine and organize required information. Step 2. Determine any constants in the equation. Step 3. Rewrite equation. Step 4. Differentiate each part of the equation. Step 5. Putting it together. Step 6. Therefore statement. Step 7. Explain the meaning of the derivative. Step 1. Determine and organize required information. All we need to know to solve Part B is the given equation. Step 2. Determine any constants in the equation. The value for MO will not change, therefore it is a constant, with a value of 100. When we differentiate, this value will not need to be differentiated because it is a constant of the whole equation. Step 3. Rewrite equation. Differentiation is linear, therefore it is easier to differentiate parts of the equation separately and then put it back together at the end. To make it easier to see the separate parts of the equation, we will rewrite it to be MPO at T equals 100 times F at T minus G at T, where F at T equals 1 and G at T equals 1 over 2 to the power of T over 3.8. Step 4. Differentiate each part of the equation. We'll split up Step 4 into 2 parts to make it easier to solve. Step 4.1. Differentiate F at T equals 1. Step 4.2. Differentiate G at T equals 1 over 2 to the power of T over 3.8. Step 4.1. Differentiate F at T equals 1. We will use the constant rule to differentiate this equation. The constant rule states that if f at x equals c, where c is a constant, then f prime at x equals 0. Since f at t equals 1, f prime at t equals 0. This makes sense since the derivative of a function represents the slope of the tangent at any given value of x and the instantaneous rate of change of y with respect to x. Since f at t is constant, there is no instantaneous rate of change, and the slope of the tangent at the value of t is 0. Step 4.2. Differentiate g at t. We will use Leibniz notation and chain rule to differentiate this equation. Leibniz notation is a notation developed to express the derivative of y equals f at x in terms of dy over dx instead of y prime or f prime at x. And chain rule states that if f at x equals g times h at x, then f prime at x equals g prime times h at x times h prime at x. If used together, Leibniz notation and chain rule state that if y equals f at u and u equals g at x are differentiable functions, then dy over dx equals dy over du times du over dx, where dy over du represents the outside function and du over dx represents the inside function. Follow these steps to use Leibniz notation and chain rule to differentiate g prime at x. Step 4.2.1. Determine dy over du and differentiate. Step 4.2.2. Determine du over dx and differentiate. Step 4.2.3. Determine dy over dx by multiplying dy over du by du over dx. Step 4.2.1. Determine dy over du and differentiate. dy over du uses the outside function, MPO equals 1 over 2 to the power of u. Therefore, dy over du equals 1 over 2 to the power of u. We will use the derivative of an exponential function rule to derive dy over du. The rule states that if y equals b to the power of x, y prime equals ln b times b to the power of x. In our case, y prime equals dy over du, b equals 1 over 2, and x equals u. Therefore, dy over du equals ln 1 over 2 times 1 over 2 to the power of u. Step 4.2.2. Determine du over dx and differentiate. Du over dx uses the inside function. Therefore, du over dx equals t over 3.8. We will use the linear function rule to differentiate du over dx. The linear function rule states that if f at x equals a times x plus b, then f prime at x equals a. In our case, f prime at x equals du over dx. A equals 1 over 3.8, x equals t, and b equals 0. Therefore, du over dx equals 1 over 3.8 times t plus 0. Du over dx equals 1 over 3.8. Step 4.2.3. Determine dy over dx by multiplying dy over du by du over dx. dy over dx equals dy over du times du over dx. Then dy over dx equals ln 1 over 2 times 1 over 2 to the power of u times 1 over 3.8. However, the derivative must be in terms of t, since u equals t over 3.8, replace u with t over 3.8. Therefore, g prime at t equals ln 1 over 2 times 1 over 2 to the power of t over 3.8 times 1 over 3.8. Step 5. Putting it together. Here we have our rewritten equation. Now we can sub in everything and simplify. To find that MPO prime at t equals negative 100 over 3.8 times ln 1 over 2 times 1 over 2 to the power of t over 3.8. Step 6. Therefore statement. Therefore, the first derivative of the function MPO at t is negative 100 over 3.8 times ln 1 over 2 times 1 over 2 to the power of t over 3.8. Step 7. Explain the meaning of the derivative. As we note, the first derivative equation models the instantaneous rate of change, slope, at every point on the function. Therefore, in this situation, the first derivative is the rate of change of the amount of polonium in milligrams per day. Referring to the graph, we can see as the days go on, the rate of change of the amount of polonium in milligrams per day decreases, which makes sense since there is less radon available to decay and form polonium as the reaction continues. A career that would use exponential decay of an element would be chemical engineering, since they would have to study the rates of a reaction.